Good evening, and welcome to Story of the Cosmos. Tonight, we start in this quiet room and travel outward, rung by rung, all the way to the true edge of what can ever be seen. Right outside your window, the night sky looks close enough to touch. It isn't. Somewhere beyond the curtain, beyond the street light or the rooftop next door, real darkness begins, and in it, points of light so ordinary you might not think to count them. If your sky were truly dark, free of any city glow, you could make out perhaps 9,000 stars scattered across the whole sky. Only half of those sit above your horizon at any one moment. The rest are hidden beneath the world, waiting their turn to rise. 9,000. That's all the naked eye has ever offered anyone. Every ancient sailor, every shepherd, every person who ever lay in the grass and looked up. It's a small, honest number. And yet the sky isn't blazing with light, wall to wall, star pressed against star, the way it would if the universe stretched back forever in every direction, unbroken and eternal. It's dark between those points, dark enough to sleep by, because the universe had a beginning, and light from almost everything out there simply hasn't arrived yet. Behind that darkness, behind those 9,000 ordinary points, lies almost everything else. A star, 7 other worlds, countless more stars, galaxies beyond galaxies, and somewhere far past all of it, a horizon that marks the very limit of seeing. The rest of the sky is only just beginning. Light left the moon a little over a second ago, and already it has reached your eyes, barely longer than a heartbeat. Step back a little further, and the sun's light needs 8 minutes and 20 seconds to make the same crossing, far enough that if the sun blinked out this instant, the room around you would stay lit, warm, and none the wiser for most of 10 more minutes. From here, the journey outward begins in earnest. Past Mars, a rust-coloured wanderer whose light lags behind the sun's by many minutes more. Past Jupiter, so large that the smaller worlds nearby move as if pulled by an unseen tide. Past Saturn's rings, Uranus tipped strangely on its side, and Neptune, cold, blue, and in most people's imagining, the edge of everything the sun holds on to. It isn't. Neptune is only a marker along the way, not a boundary. Beyond it drifts a thinning scatter of icy fragments, and beyond that, almost nothing, for a very long while. A darkness so complete it can feel like empty space itself has taken over. And yet, the sun's gentle grip has not let go. Somewhere out past 1,000 times the distance from Earth to the sun, and continuing on beyond 5,000 times that distance, lies the Oort cloud, a hollow shell of countless icy bodies, drifting so slowly, so far from any warmth, that a single orbit can take longer than the whole of recorded human history. This is the solar system's true edge. Not a line on a diagram, but a slow, dark, three-dimensional shell, wrapped almost entirely around the sun, holding on by gravity alone, so faint and so distant that no spacecraft has ever photographed it, and none may for a very long time to come. It is worth sitting with that for a moment. The sun, the source of every warm afternoon and every shadow you have ever cast, reaches its true limit only after wrapping a swarm of frozen debris around itself at a scale that makes the 8 planets look like a tight little cluster near the front door. And still, this is only the solar system. One star, with its one small huddle of worlds, and its one wide, ghostly shell of ice, floating in a darkness so vast that the nearest other star is a story for later. A story that begins the moment you leave this shell behind, and keeps going, rung by rung, for a very long way still to come. For now, simply notice how far home already turns out to be. A single machine, built in 1977, is still out there talking to us, and its voice now takes a full day to arrive. Its name is Voyager 1. It left Earth before most of the people watching this were born, riding a gravity-assisted tour of the outer planets that was only ever supposed to last a few years. It kept going. In 2012, it crossed the heliopause, the faint outer edge of the Sun's bubble of solar wind, and slipped into interstellar space, the first human-made object ever to do so. It is tempting to say it left the solar system that day. It didn't, not really. The Oort cloud, that wide shell of ice we just passed through in our minds, still waits ahead of it. NASA's own estimate gives Voyager something like 300 more years just to reach its inner edge, and perhaps 30,000 years to pass beyond it entirely. Leaving the Sun's light is not the same as leaving the Sun's family. Still, the distance it has already covered is almost impossible to hold in the mind, honestly. This November, in 2026, Voyager 1 will reach a strange and quiet milestone, a full light day from home. Send it a command, and the radio signal, traveling at the speed of light as fast as anything can ever move, takes 24 hours just to reach the spacecraft. The reply takes another 24 to find its way back. A conversation with Voyager 1 has the rhythm of a letter sent by ship. But before any of that, in 1990, something gentler happened. At the request of the astronomer Carl Sagan, ground controllers turned Voyager's camera around, away from the stars it was chasing, back toward the tiny, distant light it had come from. From 3,700,000,000 miles out, it took one photograph of Earth. In the image, our entire planet, every ocean, every mountain, every person who has ever lived, appears as less than a single pixel, caught almost by accident in a stray beam of scattered sunlight. That photograph is worth holding on to now, early in this journey, because the distances ahead are only going to grow stranger. Whatever scale we reach from here, however small Earth comes to seem, this is the picture to return to. A pale, quiet dot, still shining where we left it. And so it rests. A journey outward, Proxima Centauri, and how we measure distances we can't reach. Even light, the fastest thing there is, needs 4 years and 3 months just to reach the next star over. That star is Proxima Centauri, a faint red ember of a sun, far too dim to see with the unaided eye, sitting 4.25 light-years away. Nothing built by human hands has ever come close to crossing that gap. It would take even our fastest outbound spacecraft tens of thousands of years just to arrive. And yet Proxima Centauri is, in cosmic terms, next door. It is the nearest star there is. Beyond it, the distances stop being measured in years and start being measured in something closer to abstraction. So how does anyone claim to know how far away a galaxy sits, when even its nearest starlight is unreachable? The answer is a kind of ladder, built one rung at a time, each rung trusting the one below it. The first rung belongs to a class of star called a Cepheid variable, a star that pulses, brightening and dimming in a rhythm as steady as breathing. Early in the last century, an astronomer named Henrietta Swan Leavitt noticed something quietly remarkable. The length of that pulse reveals the star's true brightness. Compare that true brightness to how faint it looks from here, and the distance falls out of the math. Cepheids carry that method out to about 100 million light-years. Beyond that, the ladder needs something brighter still, and finds it in dying stars. Certain exploding stars, called Type Ia supernovae, burn with almost exactly the same intensity wherever they occur, making them visible and measurable across billions of light years. It was this kind of measurement, in 1929, watching 24 galaxies and noticing that the farther one sat, the faster it seemed to rush away, that first revealed the universe was expanding at all. Rung by rung, that ladder is how the darkness gets its distances measured. The band of pale light arching overhead on a clear night, the one people have pointed to for thousands of years without ever quite knowing what it was, is home. The Milky Way's visible disk, the shining spiral you can actually trace with your eyes, stretches about 100,000 light-years from one edge to the other. But that bright disk turns out to be only the inner room. Recent surveys have traced the galaxy's outer halo, faint arcs of ancient stars and unlit dark matter, reaching far past anything the eye could ever pick out. And they place the true edge of the Milky Way nearly 10 times farther out, almost 950,000 light-years from its center. Almost everything we call the Milky Way, the part with a name and a shape, is only the innermost fraction of something much larger. And that larger structure is full. Somewhere between 100 billion and 400 billion stars turn slowly within it. Suns beyond counting, the vast majority never to be seen by anything alive to notice them. And yet, step outside on the darkest night you can find, far from any city's glow, and look up, and all of that vast population offers you only a glimpse. Astronomers who have counted carefully put the number of stars visible to the naked human eye across the whole sky in every direction at a little over 9,000. And because half the sky always sits below the horizon, wherever you happen to be standing, only about half of those, something like 4,500, are actually up there for you to find at any one moment. 9,000 points of light, drawn from hundreds of billions. There is a strange kind of honesty in that. The sky has never pretended to show you what it holds. Every star chart, drawn by every civilization before the telescope was built, from that same thin sliver, a rounding error of a rounding error, mistaken, quite reasonably, for the whole of creation. Rung by rung, this is where the ladder has carried us so far. From a shining disk 100,000 light-years across, to a true boundary nearly 10 times wider, to one galaxy holding more suns than there are grains of sand on a very long beach. And still, this is only one house on the street. A street has more than one house on it, and so does a galaxy. Step back now from the Milky Way's 100 billion suns, and something else comes into view around it. A small cluster of galaxies, bound together by gravity, drifting through space as a single, loose family. This is the local group. Andromeda belongs to it too, along with dozens of smaller, dimmer companions, most too faint to hold a name in casual conversation. It feels, at this scale, almost cozy, a neighborhood you could imagine walking. But the neighborhood itself sits inside something larger. The local group is only one small pocket within the Virgo supercluster, and the Virgo supercluster in turn is just one lobe of a structure so vast it resists ordinary language, the Laniakea supercluster. Laniakea. The name comes from Hawaiian, and it means immeasurable heaven, chosen by the astronomers who first mapped its true shape in 2014. What makes Laniakea remarkable is not only its size, though the size is staggering enough, a basin holding some 100,000 galaxies spread across more than 500 million light-years. What makes it remarkable is how it was found at all. Astronomers didn't simply measure distances outward the way you might with a tape measure. They watched how galaxies move, tracing the quiet, invisible currents of gravity that pull entire galaxies toward a shared center, the way water finds its way toward a drain. A supercluster, then, is not a place marked by a boundary line. It is a boundary drawn by motion, a watershed of galaxies, all flowing, however slowly, toward the same gravitational low point. Stand inside that idea for a moment. Every star you have ever seen with your own eyes, every galaxy in every photograph, the Milky Way itself with its 100 billion suns, all of it is just a single current within one basin, among what may be countless others scattered across a universe too large to fully map. Laniakea is a neighborhood built not from distance, but from belonging, from which way, in the end, everything happens to be drifting. And even a heaven this immeasurable is not the edge of anything. A patch of sky the size of a pinhead, held at arm's length, once seemed like the emptiest place astronomers could point a telescope. And so, in 1995, that is exactly where they pointed the Hubble Space Telescope, a sliver of darkness near the Big Dipper, chosen precisely because it held no visible stars, nothing to distract the instrument, nothing anyone expected to find. Then they let it stare there for 10 uninterrupted days. 10 days of a telescope that precious is a costly wager to make on nothing. It was a bet that emptiness might be hiding something. It was not empty. When the long exposure finally resolved, very close to 3,000 galaxies appeared out of what had looked like blank night. Some of them so distant their light had been crossing space for 12 billion years before it reached that mirror. They had been sitting there the entire time, in that same sliver of sky, simply too faint for any eye or any earlier instrument to notice. It helps to remember here that a telescope looking outward is also looking backward. Light takes time to cross a distance, so the farther out astronomers look, the further into the past they are seeing. Not a metaphor, but the plain mechanics of it. Decades later, the James Webb Space Telescope turned toward a different patch, one bent and magnified by the gravity of a massive galaxy cluster acting as a lens of pure space. In just 12.5 hours, a fraction of Hubble's 10 days, it reached comparably deep, and then further still. And in a deeper survey that followed, called JADES, Webb found a galaxy seen as it looked less than 300 million years after the very beginning. A smudge of light, barely 1,600 light-years across, glowing far brighter than anything that young was supposed to glow. Later, astronomers looking closer into that same ancient smudge found oxygen inside it, an element with no right to exist so early, forged and scattered only after generations of stars had already lived brief lives and died. And even that record did not hold for long. Within months, a fainter, more distant smudge was found sitting further back still, quietly pushing the edge of the known past a little further into the dark. Every one of these are not paintings of some other place. They are photographs, real light, really old, arriving only now. What looks like empty sky has never once been empty. It was only ever waiting to be looked at long enough. Point a receiver at any patch of sky, anywhere, in any direction, and it still hears the same faint hum. A whisper, left over from the universe's very first light. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were trying to track down an annoying static in an antenna in New Jersey. They rewired it, they cleaned out pigeon droppings, they checked every possible fault, before realizing the noise wasn't a flaw in their equipment at all. It came from everywhere at once, with no direction to point away from. What they had stumbled onto, without meaning to, was the afterglow of the universe's own birth, light released when the cosmos was only 380,000 years old, now cooled to barely 3 degrees above absolute zero, spread almost perfectly evenly across the entire sky. The discovery earned them a Nobel Prize. Its greater value came later, when space telescopes turned toward that same glow and learned to read it like a clock. Tiny variations in its temperature, ripples too faint for any antenna to notice by accident, let astronomers work out, with extraordinary precision, exactly how long light has been traveling since that first release. Different instruments, different methods, different teams, all arriving at the same answer: 13,800,000,000 years. The most careful measurement yet made narrows that number to within 1/10 of 1%. Think of it as warmth, not just light. The faintest possible warmth, filling every direction at once, cooled by billions of years of expansion until it registers as almost nothing, a few degrees above the coldest cold there is. And yet it is still arriving, tonight, everywhere, older than every star that has ever burned and every galaxy that has ever formed. It was already ancient before the sun existed. The oldest light still finds us. Draw a sphere around this room, 46.5 billion light-years in every direction, and you have just traced the outer wall of everything you are permitted to see tonight. 93 billion light-years across, from edge to edge, the observable universe. The true horizon. The end of the road this whole climb has been building toward. Something about that number seems wrong at first. The universe itself is only 13 8/10 billion years old, a figure measured now with startling precision, uncertain by barely 1/10 of 1%. So how can light that set out almost at the beginning have crossed a gulf more than 3 times wider than that age would seem to allow? The answer is that the light was never crossing a fixed distance. It left its source billions of years ago, and while it traveled, the space it was moving through kept stretching, quietly, everywhere, all at once, the whole time. By the time that ancient glow finally reaches an eye or a telescope tonight, the point it set out from has drifted far, far beyond where it once stood. Distant galaxies can even recede from us faster than light itself, and nothing breaks in that. It isn't motion racing through space. It is space itself, widening between 2 points that were never really rushing anywhere at all. And there is a quieter, stranger thought folded inside that horizon. It is not a wall built somewhere out in the cosmos, the way a shoreline has an edge. It is simply the farthest that light has had time to travel since everything began, measured outward from wherever the measuring happens to start. Stand in this room, and the horizon is centered on you. Stand instead on some ordinary world, circling some ordinary star, 10 billion light-years off in another direction entirely, and a different horizon closes around that window, just as vast, just as complete, just as convinced it sits at the middle of everything. There is no true center. There never was one to find. Every watcher gets their own edge of everything, and even that edge is not fixed for good. Some of the galaxies glowing quietly overhead tonight will, given enough patient eons, drift beyond reach and slip from view forever, carried off by the very stretching that let their light reach us in the first place. This is as far as seeing goes. Coming home to a pixel of light. And from that edge, the only direction left is back, down through every rung climbed to reach it. Down past the basin of 100,000 galaxies that flow, together, toward a shared center, astronomers named for the Hawaiian words for immeasurable heaven. Down past the local group, past the 100 billion stars of our own galaxy's true, barely visible edge, through a spiral arm, toward one ordinary yellow star. Somewhere along this descent, the Milky Way's slow future waits quietly in the dark. For decades, it was told as a collision, our galaxy and Andromeda locked on a 4 billion-year course toward impact. But look closer, as newer surveys have, and the picture softens. It may still happen, or it may not. Recent recalculations, run across 100,000 simulations, put the odds nearer to a coin's toss than a certainty. And even if it comes to pass, almost nothing would truly collide. The space between one star and the next is so vast that even two galaxies merging, slowly, over billions of years, would likely see every star glide past its neighbors untouched. Less a crash than a long, gentle tide. Closer still, Proxima Centauri fades behind. The Oort cloud's icy stillness gives way to the thinning edge of the Sun's own bubble, where one small spacecraft keeps crawling outward, its signal now nearly a day old by the time it's heard. But turn back with it, just once more, to 1990, to the photograph a scientist asked for against every practical reason not to take it. In that frame, seen from 3,700,000,000 miles out, Earth is not even a full pixel. Just a mote, caught and held in a scattered ray of ordinary sunlight. And still, everything this journey passed through, the hydrogen lit into the first stars, the iron forged and scattered by dying ones, the light bent by unseen gravity, the slow stretching of space itself. It is not separate from what waits in a quiet bedroom tonight. The same material, the same old light. Nothing to fear in that pixel. Only home. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you, until the next journey.